Thank you all for attending the fall webinar of the University of Miami Miller School of Medicine Comprehensive Center for Brain Health. I'm Dr. Michael J. Kleiman, a postdoctoral research fellow here at the CCBH. Today, I'd like to discuss a fairly esoteric field of study, but one that's gaining a lot of traction lately. That would be the application of speech analysis to measure cognitive functioning in both healthy aging and in dementia. Let's start off by talking about healthy brain aging. As we age, very mild cognitive decline occurs, and is most noticeable past the age of 65 or 70. This can manifest as forgetting someone's name, misplacing objects, or difficulty remembering the right word in a sentence. For the most part, this is normal. As we age, the part of our brain called white matter degrades gradually. You might be familiar with the term. Our brains are made up of both white matter and gray matter. Gray matter, which is actually pinkish gray, are the actual brain cells themselves, while the white matter, which looks like a whiter shade of pink, acts like a network in the middle of the brain to connect the neurons to each other. This white matter is actually made up of something called myelin, which coats the long neurons in a similar way to how a wire is coated on the outside with rubber. This coating causes the electrical signals in the neuron to travel a lot faster than if it were uncoated. You can see that the neuron on the right, which is coated with myelin, has a much faster electrical signal than the uncoated neuron on the left. As the myelin degrades due to aging, signals get slightly slower, making it more difficult to perform cognitive tasks that require a large degree of interconnectivity between regions in the brain. One of those tasks is speaking. The act of speaking is neurologically very complex. When you're preparing to speak, you first think of the idea of what to say. Then you think of the words, which then travels to the part of the brain in charge of actually producing the sounds of the speech. The reverse happens when you listen. You process the sounds, which get further processed as words, and then the idea behind the words. As we age, these connections slow down, leading to things like slower speech, less diversity in the types of words we use, and the use of simpler phrasing and colloquialisms. I like to think of this reversion to simpler and less diverse phrasing as a case of a very large library. Say that there's a library with a large number of bookcases. The more general books are in the front, and the highly specialized books on particular topics are in the back. When we're young, it's easy for us to run quickly to wherever we need to, whether that's a particular spot in the front or all the way in the back. As we grow older, we walk a bit slower. So instead of choosing to walk towards the back of the library to retrieve a specific book, we instead opt to walk maybe halfway to get a book that fits the purpose, but maybe isn't the absolute best choice. This doesn't mean that it's impossible for us to get to the back of the library, but if we don't need to, say if there's an acceptable but not perfect match, we opt to save the energy instead. Choosing words or phrases is similar. As we age, the white matter coating begins to break down just a little bit. That causes connections within the brain to also slow down. If it takes too long to think of the best word choice, we often fall back on more common, easily accessible words or phrases that may not be the best choice, but are close enough. Pathological or disease-driven decline is a bit different. Depending on the type of disorder, there's often a much more pronounced decline in speech, because instead of the connections simply being slightly slower as in normal aging, suddenly individual neurons or even whole networks are stopped altogether. In Alzheimer's disease and Lewy body dementia, the degradation is fairly widespread, leading to more hesitations and pausing and less organized speech overall. But speech doesn't completely shut down until much later stages, where the degradation is more severe. In vascular dementia or stroke, damage can often be a lot more localized, sometimes directly in speech-related areas, which can affect speech patterns, speech production, as well as aphasia entirely. If you take a look at the differences side by side, it's easy to see what's normal and what's not. In healthy decline, you have a slightly slower rate of speech that's a bit more subtle, whereas in pathological decline caused by Alzheimer's, that rate of speech is greatly slowed and is actually very noticeable. In healthy decline, you trend towards using a bit less complex words, whereas in pathological decline, the majority of the words that are used are simple. In healthy decline, you might occasionally lose track of what you're saying, but in pathological decline, you could frequently restate phrases, sometimes multiple times within a few minutes. In healthy decline, you might infrequently stutter and stumble over a word or two, but in pathological decline, you might even have trouble saying words entirely. But these changes don't only occur in later stages of dementia. Because dementia is progressive over the course of years before it is often diagnosed, these changes in speech behavior often start to occur before other types of cognitive changes become obvious. It's important to keep in mind that not everyone who has a biomarker of Alzheimer's will actually go on to develop Alzheimer's disease. So being able to predict who will become impaired is critical to testing new drugs and therapies. In studies that follow cognitively normal participants with some evidence of dementia biomarkers over many, many years, those who eventually go on to develop dementia are found to have reduced diversity in their word choices. Pauses and hesitations like and normally increase with age. However, some studies suggest that the rate and length of those pauses increase in very early Alzheimer's compared to healthy controls. If you're trying to detect early impairment, though, it's critical that you choose the right type and category of speech assessment for the job. There are two categories of assessment based on the two types of speech: connected speech and unconnected speech. Connected speech is basically just natural discourse. Each word choice is connected to each other word in a continuous phrase. This contrasts with unconnected speech. In these types of tasks, participants are asked to retrieve separate words that may be semantically related to each other, as in naming as many vegetables as you can think of, but aren't connected in a full sentence or phrase. Each is affected by both age-related and pathological decline. However, unconnected speech is more easily and widely researched, and that makes sense. It's a lot easier to count the number of words that a participant can think of than it is to calculate how diverse one's vocabulary is within a phrase. But the benefit of connected speech is that it is more sensitive to subtle or widespread neural impact, as there are far more neural pathways involved in describing a picture than there are in remembering a series of words. This means that connected speech is able to detect much more mild impairment and can even be used to assess decline in normal aging, whereas unconnected speech tasks are a bit less effective. Unconnected speech tasks are fairly easy, both to take and to analyze, as they only involve single word production. The semantic and verbal fluency tasks require participants to remember as many words as they can from either a semantic category, like tools or vegetables, or a letter-based category, like all words that begin with the letter A. These tasks measure word recall from long-term memory, as well as speech production, and are included in many neuropsychological batteries. The object naming task is another unconnected speech task that involves simply saying what an object or picture is. This task is usually not impaired until later stages of dementia, because it involves fairly robust, high connectivity pathways of language production that typically aren't affected until most of these pathways begin to deteriorate. As a result, it isn't very useful for measuring normal age-related decline or very mild impairment. In connected speech tasks, we encourage participants to engage in natural speech production by asking open-ended questions like describe your typical Sunday, or by eliciting complex descriptions or explanations of a picture or scene. The connected speech task with the simplest administration is the spontaneous speech task. Essentially, you just need to answer an open-ended question, like what do you do on a typical Sunday, or how do you get yourself ready in the morning? Even though everyone will give completely different answers, you can still calculate things like rate of speech, diversity of word choices, frequency of pronoun versus verb usage, rate and length of hesitations, and so on. It can be problematic, however, if you don't have a typical schedule on Sundays, or if you do very few things in the morning. To mitigate this, it can be useful to instead have a more guided prompt, while still capturing natural production of speech. A picture description task is a great way to promote natural discourse while ensuring that the subject matter is relatively uniform between participants. To start, a participant will be given the prompt, "Tell me everything you can see happening in this picture," with very little additional guidance. From their description, we can gather similar metrics as the spontaneous speech task, with the addition of being able to measure what percentage of the picture they described, as well as whether they are correctly interpreting everything that's happening. For example, in this picture, you can see a boy standing on top of a stool, trying to grab cookies from a cookie jar. A girl is reaching out to try and grab a cookie. The mother is washing dishes, but she's not really paying attention and she's letting the sink overflow. Someone that's healthy will easily be able to name everything in the picture, whereas someone that's impaired might not say everything in the picture. They might misinterpret things happening, or they could say the same thing multiple times. Once we have audio recordings and transcripts from each of these tasks, we can then dive into the small details hidden inside them. There are over 100 different individual measurements that we can take from speech. Some of them give us a big picture, while others allow us to measure very small changes in particular types of cognitive functioning over time. Some of these are related, like hesitation length and rate of speech. However, most of these elicit different types of cognition that each require different neural pathways. After collecting all of this data, we can use it to not only measure a single person's cognitive functioning, but paint a broad picture of what both healthy aging and dementia looks like across different groups, races, and ethnicities. A large portion of my research examines each of those individual speech measurements and looks at how each of them decline over time in both healthy older adults and in people with some cognitive impairment. I can look at brain imaging to identify which regions are associated with degradation in certain types of speech. I can also look at how each of these may or may not degrade in relation to other data points, like lifestyle choices, physical health, amount of mentally stimulating leisure activities, socioeconomic status, race, and ethnicity. By researching these associations, we become better able to understand how and why speech and language are differently affected in varying groups of people, allowing us to potentially identify dementia earlier, or even develop strategies to help us maintain our brain health throughout our lifespans. Soon, we'll even be able to test you from the comfort of your own home, just like how you're watching this webinar right now. Thank you so much for your attention. If you have any questions for me or the other speakers, please leave them below using the Q&A button. I look forward to addressing your questions shortly.